computation should be relatively straightforward for everybody. Just go to python.org, download whatever the current version is, which is what, 3.11.1 or whatever it is, for your target system, which for most of you is either Windows or Mac OS. And because I think we've only got one Linux jockey in the room. Woo! Oh, two Linux jockeys. Yeah, okay. Good. So yeah, get that installed, and then when you first fire up VS Code and create a Python file, if you name it something.py, then VS Code will sort of auto-recognize that you want to do it in Python. The very first time you do that, it'll ask you if you want to install some VS Code extensions for Python. Just say yes to that, and then the syntax highlighting and everything will look really cool. And it should auto-detect all of the Python configurations, so it should be pretty foolproof. Yeah, okay, anyway. So, good. So last time we were talking a lot about data types, and I want to spend part of today talking a little bit about some math, and also like how do you do mathematical computations. And then also kind of do some exercises, kind of some live coding together on just some simple kind of coding problems. So nothing that's particularly rocket science. But yeah, let's do some computations that we might need to do in a mathematical context. So for example, I think last time we said you might have some grades that you want to compute. Like, let's say we want to average some numbers. So let's just come up with a couple of numbers. How about, give me a number. 43. Man, you really tanked it on that quiz. All right, what's another one? Of course. Uh-huh. Any other suggestions? 90, what? 96. Okay. Yeah, uh-huh. 4, okay. Okay, so wildly volatile performance on your quizzes or whatever. How would we average those? Well, how do we average numbers? Yeah, we just need to add them all up. Okay, and I'm being a bit inefficient here by not defining an array of them or something. And then in this case, how many numbers are there? 5. Okay, so I divide by 5. And then what do I want to do? I want to print the average. Okay, but I could be a little bit more fancy and say the average something like this. Okay, so what am I going to print there? The print function, if I give it a thing that's comma separated list, then it will just print those things after each other. Okay, so this is a quick way that you can have, explanatory text to what you're printing rather than just printing a bunch of numbers. Okay, so all right, so any issues with that? Look okay? All right, so let's run it and make sure that it works. Oh, wrong mouse, that would help. Okay, and I guess I didn't need this space here. I would have in C. And so, okay, the average is 62.4. Great. Yeah, nothing special. Yeah. Okay, let me see. Okay. Here, let's do this. Let's do new file. You did a Jupyter notebook?
I think.
Not a Python file.
Oh, okay.
So yeah, just use a regular Python file.
So every time I click, I just don't.
Yeah. So, and thanks for reminding me about that. I forgot. So, you guys may have heard of these things called Jupyter notebooks. Has anybody used them before? I think they sometimes use them in physics classes. Um, Jupyter notebooks are kind of a way that you can integrate Python within a document. And so you could have like, almost like imagine embedding Python windows into like a Word document. So you can type like normal and have marked up text that looks nice, but then also have Python stuff in it. Maybe another way to think about it is it's kind of like the idea of a Mathematica notebook. And you guys probably, who's done at least Calc 1 or something and done something with Mathematica, right? Where you can have text cells and you can also have code input output cells. And so you could write a Mathematica document that has like a bunch of explanation and then you do some computation and then you got some more explanation and stuff. You can do this with Jupyter notebooks. And we won't deal with those, at least for not right now. So when you create a new Python file, don't create it as a Jupyter notebook, create it as just a Python file. That's it, bare Python, okay? That good? So yeah, thanks for that, Mark. Okay, so anything else that works? No big deal, right? What's wrong? It's not working? Well, is this a PEPCAC error? Probably exists between keyboard and chair? Yeah, okay. Well, I'll look at it in a minute. Okay, so great. We just did a bunch of math. Now, one thing, right, when I defined all of these numbers, what's the data type of all the numbers, num1 through num5? These are all of type int, right? And when I add them together, what is the resulting number? Also type int. And when I divide by 5, now it's going to be of type float, okay? So what the average is of a floating point value, and that makes sense because it's sort of rare that your average is going to be exactly a whole number. Okay, so so that data type conversion has happened. Okay, and Python just does it for you basically, which is both nice and also terrible. Okay, now let's do some other math here, and let's look at a couple of other operators that are really useful. Okay, so there's I think 27 of you enrolled in the class. Okay, great. Let's suppose that I have 36 donuts that I can give to everybody in the class. Okay, so 36 donuts, there's 27 of you. So how many donuts do you each get? 1 point something, right? All right, but are we really going to go through the trouble of cutting up those leftover donuts and giving you your extra little piece of donut, or are you all just going to be happy to have a donut each, and then there'll be some leftovers that I take back to my office or something? Okay, or maybe I save the extra donuts as bonus donuts for whoever answers the question really well or something. Okay, so if I were to compute, for example, 27 students, or sorry, 36 donuts, so I've got 3 dozen donuts, and I'm dividing them by the 27 students, then what is this going to output? Yeah, it's going to output 1.3 repeating in this case, right? Because there's some leftover donut. Okay, maybe actually cutting them into thirds is not the end of the world. That's not too hard. But like, imagine that I only had like 29 donuts, right, or something, where the fraction is not going to be. How do I cut a donut into a 0.07 part of a donut? It's going to be real messy real fast. Okay. All right. So let me go back to the 36 case. So here I'm doing this division, but the result is floating point, and I'm sort of essentially doing floating point division. Okay. But let's go back to the case of where, let's say that I wanted to only give everybody exactly 1 donut, right, which would make sense. How could I do the computation so that the answer here is 1 and not 1 point whatever? Okay, that's sort of the question. Now, there's 2 ways to answer that question. Okay, what's one way? Rounding, right? I could take the answer and say round it down to the nearest integer. Okay, so that would be one solution. What would potentially be another solution? This one's more subtle, I'll grant. Ignore the remainder. So do the division as an integer division where you think of division not as, so like think back to when you guys first learned division in elementary school. Okay. If I had asked you when you were in fourth grade to divide 36 by 27, and you'd set up the little thing and you'd go through it, right? You would have said, okay, the answer is 1, remainder 9 in this case. Okay. And you would have called that good, right? So that kind of division is integer division, where you just say, oh, and the remainder is 9. Okay. And we'd like to be able to do, well, for a couple of reasons, to be able to mathematically compute both that quotient, in this case 1, but also that remainder of 9. Okay, make sense? Okay, so how we could do this with rounding, let's just do that, is, so there's a couple ways, but probably the easiest is just to use the int function. Okay, so what the int function will do is basically take a number and lop off any of the decimals. Okay, all right, so let's run that and see what we get. Okay, we get 1. And now, what is 36 divided by 27? We already said it was like 1.33 blah, blah, blah. And what type is that? Float. Okay, int of a float does what? It lops off all the decimal digits. And what's the data type now? Int. Okay, so we can do that conversion. Okay, and it prints for us here 1, which is what we wanted. Okay, the other way we could have done it, which was to do the integer division. So how many donuts did I say? 36 donuts. Is to use a double division bar. Okay, and the double division bar is the symbol in Python for doing integer division only. Okay, so kind of like the grade school division. Okay, does that make sense? Yeah. Okay, so this is nice. If the double division bar gets us integer division, what else might we want to know about our donut situation? Okay, how could we compute the remainder of the number of donuts? There's two ways. Yeah, that's one way, is a modulus operator. Okay, and there is such a thing in Python. The other would be, well, we could do this. Okay, so let me actually declare some variables here. So let's say num students equals 27, num donuts equals 36, and I wanted to do, say, donuts per student, and this is the stupidest variable name ever, but so we did 36 divided by 27, and I'll do the integer version here. Remaining donuts, I could do this. Well, how many donuts do I have to start with? Well, I have num donuts. Would help if I could spell donuts correctly. And by the way, if any of you spell donut with an O-U-G-H, donut, you can just get out, okay? But on the subject of donuts, what's everybody's favorite kind of donut? All right, who's like just regular old glazed is great, okay? What about chocolate glazed? Okay. What about with sprinkles? Surely, Mr. Sparkles, you like it with sprinkles. On special days? Okay, fair. Jelly donuts? Bear claws? Am I missing any? The cake donuts? Oh, the eclairs or whatever they're called? Yeah. Oh, yeah. Okay. Those are some good donuts. Yeah. Okay. Um, well, because at the end of the semester, when we do our final project show off stuff, there will be donuts. Okay. So, anyway. Okay. So, uh, so remaining donuts, how would I compute this? Well, I would do the number of donuts minus the donuts per student times the number of students. Okay, so now let's think about what that actually is computing here. In this case, this would be computing 36 minus 36 over 20, or sorry, 36 over 27 times 27. Okay, and in this case, or not 36 over 27, it's 36 double over 27. Okay, so numerically, that's what I'm actually computing here. But by defining it, of course, in terms of the variables, if the variables change, I don't have to rechange the computation. It'll just automatically do that, right? Okay, so does it make sense how I've got that form there, right? And essentially, right, I'm doing the integer division algorithm, which where you think of it, right, as quotient and remainder. Okay, yes, sir. Yes, that's the other way to do it. Okay, so we could also do it as he suggests. So let's call this remaining donuts 2 equals, this would be 36% 27. Okay, so the percent symbol does basically computes the remainder of the division of 36 by 27 rather than the quotient. Okay, now the reason that I point out the other way of doing it with this subtraction multiplication version is because depending on the language that you're operating in, there may not be that percentage or that mod operator. Okay, in which case you have to do it the other way. Okay, and remember that in the fall when you take CS241, because there is no hard, well, depending on the architecture, on ARM architecture, the integer division, there is no machine instruction for doing remainder. On Intel, there is. So it just depends, right? Now, from a Python standpoint, we don't have to care, because if there's not, like, what Python is doing is actually that under the hood, probably, unless it's on an Intel machine, in which case there's a machine instruction to do it. So, okay, so remaining donuts and remaining donuts 2, those are equivalent. They will both have the same value, okay? They're just two different ways of computing the same thing. Okay, so and then we need to print all this and make sure that the computations are working correctly. So, question, preguntas, fragen. See? And I actually haven't explained to you guys what that means. Well, so question is French, right, for question, and pregunta is Spanish for question, and fragen is German for question. So many years ago, there was a professor of French here, Tom Stokes, and he passed away suddenly in 2015, I think it was. Just dropped dead of a heart attack one day. And ironically, he was in Canada. He was going to a conference where he was going to give a paper on waiting for Godot, and he never showed up because he dropped out of a heart attack on the way there, and so everybody was waiting for him. And yeah. Anyway, so I took French 101 and 102 from him, and whenever he was asking if people had questions, he would always say question, preguntas, fragen, and I kind of adopted it after he died, so, kind of keep the memory of him alive a little bit. So, yeah. Okay, so, but seriously, any questions here? Yes, sir. Sure. Okay, your Python doesn't work. How many of you guys are having Python install trouble? Okay. All right, so let's keep going a little bit. And then I want to do some live coding or pair coding with you guys, and then I'll look at your machines and we can figure that out. Because I want to get that stuff figured out like maintenant, so that we can actually get stuff done, right? Okay, so we need to double check that all of these things are printing correctly. So let's do some printing stuff. So how many students do we have? Um, there are how many students? Num students. Okay. And each student gets how many donuts? Num or donuts per student. Okay. And how many donuts are left over? Oops, I need a comma. Okay, so I'm just printing it with a little bit of fancy text just for sake of giggles here, right? So there are num students, okay, and this will display to us, it will appear to us on the screen as there are 36 students, or 27, sorry, there's 37 donuts, 36 donuts, 27 students, got it? Um, right, okay, so does it make sense how I set up the print command here? This isn't the only way, by the way, of printing lots of stuff together, but it's maybe a quick way. Okay, so let's run it and see what we get. Okay, there are 27 students. Each student gets 1 donut, um, and there are 9 donuts left over. Okay, looks pretty good. Yeah. Yes. Question.
If we wanted to be fancy, we could do it if else, or if donuts per student is 1, and print donuts instead of donuts.
Yes. Okay. Good point. So what's Thomas pointing out here? Should I say in this case that each student gets 1 donut? No, that's not grammatically correct in English. So there are 2 ways to fix that. The lazy way is I could put a parenthesis around the S in donuts, right? And then it would be correct, right? What's the fancy pants way would be to do what he suggested, which is have a conditional, meaning if there's only 1 donut per student, uh, do this. Okay, so let's do that just for funsies. Okay, and we'll talk a lot more about conditionals later. Okay, so so let me put some space in here. Okay, and what Thomas was suggesting is, well, what's donuts per student here? If it's equal to 1, what does that mean?
Each student gets 1 donut.
1 donut, and I wouldn't put the S. Otherwise, I would use the S. Okay. Okay, so let's look at what I just did here. Okay, I've set up a conditional expression, right? In English, and we would say it exactly the same way, right? You would never say 1 donut. You would just say 1 donut. Okay. And so the rule in English, right, is if the number is 2 or more, you put the S on it because it's plural. And if it's not, you don't. Okay. Does that make sense? Yeah. Okay. And so in essence, we've done exactly that. We said, okay, if there's exactly 1 donut per student, that's the situation where we would not put the S. Okay. And so I have my print line with the without the S on the word donuts. And otherwise, if I have any other number of donuts, including 0, by the way, right? Then you would use plural. So because you would say there are 0 donuts per student, not there are 0 donut per student. For some reason, that's just how we say it in English. I don't know why, but um, yeah. Isn't English weird? Yeah. So English is kind of I love the language because, so in French, there is l'Académie Française, right? And l'Académie Française's job is to keep French pure and not have outside influence and vocabulary and ideas from other languages creeping in and corrupting French. English has the exact opposite philosophy, right? English is like walking around in dark, seedy alleys at night and being like, finding some other vulnerable languages and like mugging them and taking their vocabulary and running off. Right, and exactly. It's really a delicious language. So, yeah, it's kind of the Borg language of the world, right? It assimilates all other languages. Yeah.
Can you do multiple if statements?
Uh, like nesting them or having multiple ones? Yes. Okay. So the question was, could you have multiple if statements? You can. Philosophically, it's recommended to try and avoid nesting them, but sometimes you just have to do that. Okay. It is, of course, also possible to have lots of if statements in your code, and of course it will. Nesting them more than 2 or possibly 3 deep is considered bad form. And there's usually a better way to think about it. Okay, but sometimes you just have to. Okay, okay. So let's look at the construction that I did here with the conditional. Right, what's the condition that I want to know? It's how many, whether or not the number of donuts per student is 1 or not. Okay, so how do I check whether or not it's 1 or not? What did I type there? Yeah, I use double equals, okay? So what does double equals mean? Yeah, Thomas.
This is a check to see if they are equal.
Right. Whereas when I defined variables up above, for example, I only used single equal, okay? Now in math, we use single equal for everything, right? Even though we really shouldn't, because what does this mean? Equals in a mathematics context has several meanings, right? If I say let x equal 5, what do I mean there? Yeah, I'm saying x is a variable and its value is 5, okay? If I write down an equation like x squared minus 3x plus 7 equals 0, some quadratic equation, what I'm asking is, well, what values of x make that statement true, right? And so I'm using equals kind of in 2 different senses in mathematical context. Now, how do you guys know how to do this? Like, how do you know which context it is? Experience of your humans, right? It's math or mathematical notation, right, is a language just like any other in the sense that there's ambiguity and there's nuance and there's context. And as people that have been studying mathematics for, well, basically most of your the time of your life where you can remember it, right? Since you were what, 5 or something, you understand that context and that nuance. The computer does not. Okay, so double equals is asking a question: is it true that nums or donuts per students is equal to the value 1? And that's a yes or no answer. It either is true or false. Okay, and an if statement requires a Boolean condition, right? So a thing that goes inside the parentheses there must be a thing that evaluates to either being true or false and no other things, okay? And then notice that I have the colon at the end of it. That's required, okay? And then notice what I did with the print statements here for each version of it. What did I do? I tab them over one spot, and that's how I know that the 2 print statements are either in the if case or in this case also the else case, right? So that's how I know the logical structure of it is just by the indenting. In other languages, you use curly braces and stuff to denote that. But in any of the curly brace languages, common developer practice was to tab over anyway, even though it wasn't required, because the curly braces are all that matters. And so when von Rossum was sort of designing Python, he was sort of thinking, well, look, everybody just tabs over anyway because it makes it easier to read and looks better. Why don't I just get rid of the curly braces and do it all with tabbing anyway from the get-go? Makes sense, right? Okay, and the other reason, of course, is finding that missing curly brace at 2 in the morning. Good freaking luck. Okay. By the way, then midnight, when midnight comes, after midnight, no programming should take place. Okay, you're better off just going to bed and coming back at it fresh. Yeah, so I know as 18 to 22-year-old college students, that sounds like heresy, but just trust me, okay? All right, so let's run it and see if it works. Okay, should it work? Yeah, all right. Well, should, right? Famous last words. Okay. And it works. Okay, so how many times did we print that each student gets a specific number of donuts? Only once, right? So even though I have 2 print statements here that say something about how many donuts each student gets, when the program executes, how many of these get printed? Exactly one of them. Okay, and which one, of course, is determined based on how many donuts there are in the first place. Okay, and in this case, there's only 1 donut. Okay, and there are 9 donuts left over. Okay, so does that sound reasonable? Yeah. Okay, so the modulus operator here is useful, right? Well, modulus and the integer division if we want to do integer division, okay? There are certainly plenty of other times where we still want to do floating point division, but we might want to round or something, okay? There are also rounding functions that you can use. Now, on the int function, what would happen if I did 1.99999 and I inted that? What would I get? 1. Yeah, okay. So what does that mean about int? It's not rounding, or maybe you can think of it as it's always rounding down. Yes, okay. But it's even better to say it's rounding towards 0. Okay, and the reason is, what would be int of negative 1.99999? Negative 1. Okay, so it's rounding towards 0. So think of the number line, right? Now that's different than the floor function slightly, because if I did floor of negative 1.99, what would I get? Negative 2. Okay, so you just have to think about that and round using the appropriate function. Okay, for floating point things, how might we want to round floating point numbers? Right. So, for example, let's say that I'm doing and we'll actually do this in a moment, something that's computing money type problems, right? With the exception of gas stations, does anybody ever use more digits than 2 for currency, or more decimal digits than 2? And for some reason, gas stations get to use 3, and they put that stupid 9 in the thousandth place. Does anybody know why we do that, or why we still do that? Oh, that, yes, I totally get the psychology, but like, why is it that it's only in gas stations that we allow that? No? Yeah. Well, yeah, who goes to a gas station to buy 1 gallon of gasoline, right? Rarely do you do that. Basically, you only do that if you're getting it to put in your lawnmower or something, right? Yeah. So I just always found that funny. And of course, there are, no, wait a minute, I think there are 2 states in the union where you can't pump your own gas. But didn't Oregon just change that where now you can? Yeah. So, but in New Jersey, it's definitely the case that you can't pump your own gas, which is kind of crazy, but whatever. Okay. So, any questions on the donuts thing? Make sense? Okay. All right. So let's do. I'll start another file here just for cleanliness. Oh, and by the way, all these files are going to get posted to GitHub. I need to do some setup stuff, but then you can just go to my GitHub repository and get at them. So yeah, okay. So let's do math demo 2.py, and Jacob, you're going to really like this. Let me write over here on the chalkboard just so we've got a reference to it. What's the formula for compound interest? Do you guys remember? Okay. So the amount of a loan or whatever, the amount accrued is the principal times 1 plus the rate, which is a percentage, over the number of compoundings per unit time, whole thing raised to the n times t power. Okay, so what are all these variables here? P equals what? Principal, right? So that's the starting amount of the loan or debt or whatever. Okay, R is the, right, interest rate in a percentage form. So like say a car loan might be 5 or 6%. Huh? So you would write it as 0.05, right? Okay. N is so T is time, and it's in some sort of units, usually years, okay, for most loans. And the N would be the number of compoundings per unit time. Okay, and for most loans, so let's say, for example, I want to go out and I want to buy a Tesla today. Okay, I would need to borrow basically $55,000 to do it. Okay, so $55,000. What interest rate am I going to get? Let's just say 5%. I have pretty good credit. And what is sort of the what length typically would you have for an automobile loan?
60 to 72 months.
Yeah, either 60 to 72 months. So that's 5 to 6 years. Okay. Let's just go with 5 year. I think that's more typical than the 72 months. You tend to pay higher interest on a 72-month loan. So let's just say 5 years, okay, which would be 72 months, or sorry, 60 months. And then in here would be what? How many times, like, what's the compounding on most loans that you take out? I mean, it depends. It's usually monthly. Okay. And it certainly is on like a savings account or some other interest bearing financial, well, maybe not. I mean, if it's like a bond or something, it might be different. But let's just take monthly. That's pretty typical for most loan or banking kind of applications. Okay. All right. So the question is basically, if I borrow $55,000 at whatever interest rate, right, how much extra money do I owe the bank beyond that $55,000? Right? So I don't just pay them back $55,000, right? Because what do we have to account for? We got to account for the interest that I have to pay. Okay. So, and of course, real loans, this is a little bit more complicated because, like, here I'm going to model it as if I take out a 55 grand loan, I buy my car, and after 5 years, I pay them every dime back right then. That's not actually how it works with real car loans, because what do? You pay a little bit monthly until at the end of that loan, the balance is now zero. Okay, but let's just run with it. This would be maybe a more accurate example would be, let's say I put 55 grand in the bank in an account at a 5%, and I will just let it sit there for 5 years. Okay, how much money would I have accrued at the end of that time? Right, that's maybe a more accurate question. Okay, so mathematically, what operations do we need to do here? Uh-huh. Yeah, so we've got a multiplication and a division, and those work exactly the way you would think that they would work, but there's also an exponentiation, right? So how do I do exponentiation on Python? Yes. Yeah, which is not what you would think it would be. Okay, so for example, let me just compute an exponential question. Okay, so let's say that I wanted to compute what's 3 squared? 9, right? And so I could write it as 3 times 3, but in math, or maybe how you guys might type this in Google or something, you might write it this way with the caret symbol. Okay, what is actually going to print here? Does that look correct? It's doing a bitwise. It's doing an exclusive OR. Yeah. So, yeah, that's not correct, is it? Okay. So maybe a better way to say it is that using the caret was not the correct notation for what we wanted to do. Okay. So the caret operator here is not doing exponentiation, even though we thought it was, because in other places, that's exactly the symbol you use. Okay, so what is the symbol for doing exponentiation? As Mr. Grant has suggested, it's double multiplication symbol, so double star. Okay, that's a little weird, but hey, that's fine. And let's run that, and of course, what should we get this time? I would hope that we would get 9. Okay, all right, so now, excuse me, now that we've cracked being able to do exponentiation, do we have all of the tools that we need to program a formula here for doing interest? Yeah. Okay, we're Gucci there. Okay, so let me just delete this. Okay, and let's define here our principal. And how much principal did we say? Let's just say 55,000. And then what's my interest rate? 5%. What's my number of compoundings? 12. What's my time? How many years did we say we were going to do? 5 years? Did I miss anything? I did that deliberately. Yeah. So time t. Because so the reason I'm doing that is I want to avoid using variables that also are functions or protected variables of other. So for example, there is a time package that you can import into Python to do things. And so I want to avoid using things that look like protected variables. Yeah. Okay, good. But do I have any other variables that I need to define here other than the formula itself? Okay, so I've got the basic pieces, okay? And so what would I do? My amount equals what? Principal times, parentheses, 1 plus interest rate divided by the number, whole thing raised to the what? Number times time t. Oops, and the parenthesis got lost. Okay, so is that have I typed everything out correctly to encode that formula? Yeah, okay. Now notice, by the way, that I've been careful to use parentheses here because one of the things you do have to worry about is the order of operations. And you have to worry about it maybe even a little bit more than you did in math class, right? Because in math class, how many operations were there? Right, addition, subtraction, multiplication, division, maybe exponentiation, we'll call that another one, right? And so what did you have as your order of operations? Please excuse my dear Aunt Sally. Did you learn it differently, those of you who grew up in other countries? Right, yeah, the other countries don't do it right. Merca, okay. Yes. No, there's different acronyms for it. So, because B, you use B for brackets instead of P for parentheses. I mean, the same thing, right? But yeah, You also use the metric system. No? No, Canada's fully metric. It's England that's not. No, it's kilometers. Yeah. Yeah, so no, England does that. So you buy your petrol in liters, but the speed limit is in miles per hour. It blew my mind when I got there. Yeah, no, Canada since the 1970s has fully metricized. This actually caused a real big problem because there was a flight, Air Canada flight, where they loaded the appropriate number of gallons, but they loaded that many liters or pounds or something like that, and they forgot to convert, and so it ran out of gas halfway to its destination. It was a unit conversion error, yeah, in the 90s. So there was a Mars probe where one NASA contractor was working in metric and another in its imperial, and they didn't convert correctly. And so the Mars probe got to Mars and then just promptly just went. So goodbye, $500 million. Yeah, somebody lost their job over that one. Okay, so I've got everything I need here, right, to do the computation. And let's see how much money I would make or owe. And so let's just print the amount. The number of compoundings per unit time. Okay, so I'm measuring time t here in years, and that's why this is a 5-year loan, but this is 12 months per year compounding monthly. Okay, so let me finish typing this and then I'll come back to that question. Okay. Okay, so the accrued amount is blah. Okay, so let's take, it's not a car loan. Let's say that I just have 55 grand and I'm going to just stick it in the bank. Okay, if I do that, what do you notice after every month on a savings account? It goes up. You're paid interest monthly, okay, even though I'm measuring time here in years instead of in months. Okay, now I could change this and I could make n equal to 1 and measure t in months instead of years. It would be like the computation would end up being equivalent, but the general formula is that. Okay. Okay, so is that okay? So that's what the 12 is signifying here. It's because I'm measuring time in years, but measuring the number of compoundings it's per month, not per year. Okay, yeah.
Is there like a function to put it in the currency, or would you just have to round like to 2 decimals?
Okay, good question. Yeah. No, we would need to round. Okay. So, for example, here, what was the accrued amount? Or if I bought my Tesla, how much interest would I be paying on my $55,000 loan? Yeah, a little over $15,000. Okay, worth of interest. Okay, over the course of that 5 years. So, what do we notice about the result that we get here? Yeah, it's got way too many decimals, so let's round this a little bit, okay? And that means we need to know, well, what is the rounding function? Well, what do you think it is? Well, let's hope it's round, okay? And one thing that's nice about VS Code, okay, is if you type a function, it will pop up one of these little helpful thingies, okay? So this is kind of like reading the documentation, but we don't want to round to an int, right? We want to round to a given precision in decimal digits. The return value is an integer if the number of digits is omitted or none. Otherwise, the return value has the same type as the number that comes in, okay? So what this means is if I do round of this 70,000 whatever, what is it going to give me? 70,580, well, it probably would be 5, but it's going to give it to me as the nearest integer. Is that what we want here? No, we want it into 2 decimal places, and so we need to specify 2 values here. What am I rounding, and how many places am I rounding it to? Okay, so how do you think I need to do that? Yeah, I'll have 2 values, okay? And so here is the syntax here is I need to say the number I want to round, comma, the number of digits I want it to round to, okay? So instead of amount, let's do round of amount, comma, how many decimal places? 2, okay? And if I run that, then it rounded up to to 73 cents instead of 72.7 cents. Okay, and that rounding, is that correct? Yeah, because that obeys the rounding rules. Okay, all right. So does that make sense? Okay, good. All right, so let's kind of put some of these ideas together and maybe do a little bit of live coding. So I'll stop the stream at this point, and then we'll kind of get our hands dirty and I'll look at y'all's computers real quick, okay? So who does not have, whose computers on which Python is not actually working where you can run stuff that you're typing in? Is it just you 2 so far? 3? Okay, anybody else? No? Okay, why don't I get you 3, come up here and let's look at it. And then I'm gonna give everybody a task and then we'll try and maybe come back together at the very end. Okay, good. Any other questions before I quit the stream? No? Okay, excellent.